Okay, now we're going to solve our equations. So 3x squared minus 4 equals 68. We got to isolate it to get it down to where it's just something squared, and then we'll square root it. So in order to do that on this first one, if I want to get it down to just x squared, think of 3x minus 4 equals 68. How would you solve that back in the day? Well, you would add 4 to both sides. So you'd have 3x, and in this case 3x squared equals 72. And then you would get rid of that 3. And to get rid of that 3, you know you would divide by 3 on both sides. 72 divided by 3 is 24. So then here's the only new step. You got to get rid of x squared. So remember, we use inverse operations. Man, the glare. How's that? Look at that. X squared equals 24. I'm trying, man. I'm missing my cable for the SmartBoard projector. So x squared equals 24. Let me just scoot you up. Maybe the glare won't be as bad then. There we go. Oh, okay. And then to undo that x squared, I think I said it, the inverse operation is to square root. So we're going to square root both sides. And this is where what we just practiced with the simplifying radicals comes into play, because you're like, oh, perfect square in 24 is 4. It's 4 times 6. Square root of 4 is 2. So we'll have 2 root 6. But here's what I want you to do from this point forward. Technically, every positive number has 2 square roots. Like the square root of 4 is 2, or also negative 2. So we're going to write this little symbol right before it, plus or minus 2 root 6. Because it could be positive 2 root 6, or it could be negative 2 root 6. Either one, when you square them, will come out to positive 24. So form that habit now, plus or minus when you square root, okay? So look at B. X squared minus 10x plus 25 equals 27. Now you might be like, oh, well, let's isolate the x squared because Mr. Plant just told us to isolate the square stuff. Thanks for paying attention. I appreciate it. But look at the left side. This is a perfect square trinomial. So we can factor this. Remember, numbers that multiply to 25 that add up to negative 10 would be negative 5 and negative 5. So this would factor into just x minus 5 squared, which, remember, if we were to then FOIL that, we would get this x squared minus 10x plus 25. That's equal to 27. Now, I see that stuff is squared. So how are we going to undo that? Square root, that's right. Good call. Sound like I'm going a little bonkers in here, guys. I'm all by myself in this room. I'm talking like you guys are answering me. So we're going to square root both sides. Square root over here. Square root over here. Now all it does on the left side is cancel out the squared. So it'll just become x minus 5 over here. Now 27 is not a perfect square, but it has a perfect square. 27 is 9 times 3. And the square root of 9 is 3. So root 27 becomes 3 root 3. But don't forget, we got to have our plus and minus. Could be positive 3 root 3 or negative 3 root 3. Now that looks bizarre, but don't worry. Are you worried? Don't worry. Last thing we got to do is we got to get rid of this minus 5. How do you get rid of minus 5? You just add 5 to both sides. Now on the other side, you always put the radicals at the back end of the expression. So we're going to have x equals 5, and then we're just going to write it, plus or minus 3 root 3. Now that technically gives you 2 different answers there. That's saying x could equal 5 plus 3 root 3, or x could equal 5 minus 3 root 3. Both answers are included, and they both work in the original equation. So let's go to C. Let's see if we can do C. Oh, Mr. Plant. X squared minus 4 equals 0. Now this one's a little easier. If we're just trying to isolate that x squared, I gotta get rid of that minus 4. Now this could be factored, sure. But nah, we're going to add 4 to both sides. X squared equals 4. And then how do we get rid of something squared? We square root it. Square root. Square root of x squared is x. Square root of 4 is 2. That's a perfect square, but don't forget. Were you about to forget? Oh, I'm not going to let you. Could be positive 2 or negative 2. So x equals plus or minus 2. If you wanted to list those separate and say x equals 2 and x equals negative 2, that's fine. Just trying to save you a little time. It's one of the things I do for you. I just care so much about you guys. All right, 4x squared minus 20 equals 5. That's our next one. So we got to isolate that x squared again. I got to get rid of minus 20. Come on. We can do that. Plus 20, no big deal. 4x squared equals 25. Come on, Mr. Blank. Give us something a little challenging here. How do we get rid of the 4? We got to divide by 4. Divided by 4, divided by 4. Now you might be tempted to say, oh, x squared equals 6.25. We're going to leave it as a fraction. Why? Because we're cool. Look at you guys. So cool, man. Can you see that? Man, red is just not happening today. Not happening. And then we have to, here, let me rewrite that. I feel guilty. There's so much guilt. Just because you guys can't see my red pen, red marker, whatever that is. X squared equals 25 over 4, and then we have to square root at the end. So, when you square root a fraction, you just square root each part. So the square root of 25, that's a perfect square. It's 5. Square root of 4 is 2, also a perfect square. But don't forget, could be positive or negative 5 over 2. So positive 5 over 2 works in the original equation. Negative 5 over 2 works in the original equation. One more. 2 times the quantity x minus 3 squared minus 8 equals 0. This is like that vertex form back in the day, right? You got your A, you got your right and left shift, you got your up and down shift, all that stuff. But we're going to isolate this set of parentheses because I see it is squared. So think of it as like if I had 2y minus 8 equals 0, it's the same steps. You would get rid of the minus 8 first by adding 8.